Okay, so in our last lesson we looked at lines with these kinds of equation where we had y equals a constant, x equals a constant. We saw that y equals a constant is always a horizontal line and through the y-axis at that constant, whatever it is. So this would pass through the y-axis at 1, that would be that line. Okay, the y-intercept we say is 1. X equals 2 would be a vertical line with an x-intercept there at 2. Okay, in this class we're going to look at introducing direct proportions, okay, which we'll talk about in a bit. Just a little definition first. One thing is just direct proportions. What are they? We say the two variables, in this case we'll be using x and y, are directly proportional if and only if y divided by x is a constant. In other words, when I divide one of the variables by the other, if I always get the same number, then we have what's called a direct proportion. Okay, so y over x is equal to some constant. In other words, another way to write that is that y is equal to some constant times x. And this is the equation of a line. We can graph these things. If we say as y equals some constant of x, well then we can have a look, we can investigate that line. Okay, remember that just means that every point on the line would have an x-coordinate, some x-coordinate, and then the y-coordinate would be whatever that constant is multiplied by the x-coordinate. So that's what the points are looking like. The parent function for all these direct proportions is the function y equals x. It's the simplest one when that constant is 1. So I'm going to investigate that on the domain from -2 to 2. Notice we have interval notation, which means we're talking about all the numbers from -2 to 2, of which there are infinitely many, and -2 is included, and so is 2 because they have square brackets around them. So I'm going to investigate it. I'm going to come up with a table of values for the function. I'm going to look at how x is changing in my table of values. I'm going to look at how y is changing in my table of values, and I'm going to look at how the quotient, the change in y divided by the change of x, is changing. Okay. Now there are infinitely many numbers between -2 and 2. I'm not going to draw a table with infinitely many rows in it. That wouldn't make sense. So I'm just going to select some of the integers between -2 and 2. So -2, -1, 0, 1, and 2. They're just the ones I'm going to look at. So the domain -2 to 2 means the input values, x in this case, can be all the numbers from -2 to 2. I'm not going to draw all the numbers between -2 and 2 because there are too many of them. Right, that would go on forever. But maybe if I select a few of them, I can see some kind of pattern emerging. The equation of the line is y equals x. That means every point on this line has an x-coordinate, and the y-coordinate is the same as the x-coordinate. So x comma y would be the same as x comma x in this case because y is equal to x. So the y-coordinate is equal to, remember what the equation is saying, the y-coordinate is equal to the x-coordinate. So whatever I put in here has to be the same as the x-coordinate. So y-coordinate has to be -2 there, -1 here, 0 here, 1 here, and 2 here. They have to be the same. If I look at delta x, remember delta we said before means the change in x as I'm moving down. In order for change to happen, of course, initially no change can happen, so something has to happen. As I move from -2 to -1, that's an increase of 1. -1 to 0, that's an increase of 1. 0 to 1, that's an increase of 1. 1 to 2, that's an increase of 1. So if I look at how y is changing, well, all the y values are the same as all the x values, so the change in y will be the same as the change in x. And then if I take all my values for delta y and divide them by delta x, 1 divided by 1 is 1, 1 divided by 1 is 1, 1 divided by 1 is 1, 1 divided by 1 is 1. They're constant. Now delta x is constant because I chose x to go up in units of 1. Y is constant because I chose y to be the same as x. Sorry, not y is not constant. Delta y is constant because I chose y to be the same as x. So the change in y divided by the change in x is constant here, it's 1. And remember, this is how I define slope. So this is saying the slope is always 1, really, is what we're saying. And even if I threw in something like, right at the end, if I put in a sudden increase of 10 here, you know, so my x-coordinate now would go to 12. My y-coordinate, remember, has to be the same as my x-coordinate, which would be 12. And again, that would give me a change in my y-coordinate of 10. The change in y divided by the change in x would still be 1 over that interval. Okay? And I can graph these. Every point can be graphed an x-coordinate, comma, y-coordinate. And I've kind of done one already out here, so that's what that looks like. Negative 2, comma, negative 2, negative 1, comma, negative 1, 0, comma, 0, 1, comma, 1, 2, comma, 2. And you can imagine that all the points in between, you know, negative a half, comma, negative a half, 0.1, comma, 0.1, you know, they're all just going to follow this line. Okay, and if I look at the slope of that line, you know, take a run of 1. Oops, sorry. Looking at the slope of this line, run 1. What's the rise? What is a run of 1? A rise of 1. Delta y over delta x, the change in y over the change in x is 1. It's going to be the same as that thing there. The slope is 1. So y equals x. Well, first of all, it's a direct proportion because it looks like this. It's a constant multiple of x. And it has a slope of 1. It has a slope of 1. And notice that's just y equals 1x, of course. The other thing to note is that every, you know, it's always going to be passing through 0, comma 0. If y is a constant multiple of x, well then, when x is 0, any multiple of 0 is just 0. So, if it's a direct proportion, it's going to contain the origin. So, a couple of things about direct proportions. They're linear and they contain the origin. So, direct proportion they're always linear when I graph them, and they contain 0, comma 0. Okay, so should know that kind of about direct proportions. An equation is direct proportion if its graph is linear and it contains the origin. Okay, so that's the first one. Let's look at another example here. Now I've said y equals 2x. Notice x and y are proportional here, because if y over x is constant, that means y is some constant multiplied by x. Here y is 2 times x. Notice the coefficient there for dx is 2, y is 1. I'm going to, again, we're looking at the domain negative 2 to 2, so I'm just going to put in values for x, negative 2, negative 1, 0, 1 and 2. There's infinitely many numbers between negative 2 and 2. I've just selected 5. Why? Well, because they're integers and they tend to be easier to deal with. In this case, the y is always double the x. So in this case, every point x comma y, you know, is going to be the same as x comma, well, y is double x. So it's going to be an x coordinate, and the y coordinate is always going to be double the x coordinate. So we're going to get negative 4, negative 2, 0, negative 2, and positive 4. Sorry, positive 2 and positive 4. So just doubling the x coordinate there to give me those. Double 1 is 2. Again, I've chosen my x coordinates to be increasing by 1. And now we'll investigate what happens to my y coordinates. Well, negative 4 to negative 2, that's now an increase of 2. Negative 2 to 0, that's an increase of 2. 0 to 2, increase of 2. 2 to 4 is an increase of 2. And if I look at delta y over delta x, change in y 2, change in x 1, it's always going to be 2. Notice that's the same as the coefficient of x. And again, if I hadn't just got up in steps of 1, if I choose to go up here in a step of, say, increase by 50, just make up a number, my next x value would be 50 bigger than 2, which would be 52. My next y value would be double that, which would be 104. Which means that my y's here have increased by 100. And if I look at the change in y over change in x, 100 divided by 50, it's still 2. The change in y divided by change in x is constant. X is changing, y is changing, but delta y divided by delta x is not changing. That is, remember, that's what we define as slope. So this looks like it has a constant slope, which means it's a linear function. We can graph it. And again, I've done the work already. I've just plotted those points. Remember, every point has an x coordinate, comma, y coordinate. So that's -2, 4. -2, -4, I should say down there. -1, -2, 0, 0, 1, 2. 1, 2, 4. And again, if I just do a quick look at the slope, a run of 1 here leaves a rise of 2. So a change in x of 1 gives a change in y of 2. So the slope here is 2, which of course we kind of knew already from our table of values, and that's the same as that number in there, the coefficient of x. Notice it's a direct proportion, so it contains the origin. And any graph, any line whose equation is y equal to some constant times x, well then we're going to have a direct proportion that is going to contain the origin. Notice the slope is always going to be the same as whatever that constant is. In this case it was 2. In the previous case it is 1. Okay? So what I want to do, just to wrap this up, is I want to look at a little GeoGebra file, and I want to think about, what's happening here. Can I look at a lot of different things rather than doing out a table of values? Use GeoGebra to help me kind of cheat a little bit. Okay, so we'll go and have a quick look at our GeoGebra file and see how that goes.